Here is a fact that will change how you think about AI. 87% of machine learning models built in 2025 never made it to production. And the ones that did? Most broke silently within weeks. That is the exact problem MLOps was born to solve. MLOps, machine learning operations, is the discipline of applying DevOps principles to the full life cycle of a machine learning system. Data ingestion, experimentation, training, deployment, monitoring, and automated retraining. Think of it this way. Without MLOps, your fraud detection model at a fintech company like Stripe quietly degrades as transaction patterns shift, and nobody notices until losses spike. With MLOps, drift is detected automatically, retraining triggers, and the new model ships without manual intervention. In this tutorial, you will learn the architecture, the core tools, and you will write real code that registers a model and triggers retraining. Let us build this properly. Before writing a single line of code, you need to understand the 5 layers of the MLOps architecture and the tools that power each one in 2026. Layer 1 is data versioning. You use DVC4 to track dataset changes the same way Git tracks code. Layer 2 is experiment tracking, MLflow. 3 logs every training run, hyperparameter, and metric automatically. Layer 3 is pipeline orchestration, Kubeflow. Pipelines 2 runs on Kubernetes and chains your data prep, training, and evaluation steps into a reproducible DAG. Layer 4 is model serving. Selden Core 2 deploys models as REST endpoints with Canary and Shadow traffic support built in. Layer 5 is monitoring, Prometheus plus evidently AI 2. Watch for feature drift and performance degradation in real time. Install everything with pip. Run pip install MLflow DVC, evidently Selden Core Kubeflow pipelines. This stack powers real production systems at companies like Spotify and Uber today. Now let us write the core of your MLOps pipeline. The goal here is to train a model. We will use a churn prediction classifier for a telecom company. Log every metric to MLflow and register the best performing version into the model registry so Selden can serve it. Walk through each step with me. First, you start an MLflow run with a named experiment. Then you load your versioned dataset using DVC. Next, you train a gradient-boosted classifier from scikit-learn 1.6. After training, you log accuracy, F1 score, and the confusion matrix as an artifact. Finally, you register the model under the name Telecom Churn Prod and promote it to the staging stage automatically if accuracy exceeds your threshold. This entire block is repeatable, versioned, and auditable. Every team member running this gets identical results because the data version, code version, and environment are all pinned. This is the foundation every MLOps pipeline is built on. A registered model in staging is great. But what happens 3 months later when customer behavior shifts because a competitor launches a new plan? Your model silently degrades. This chapter adds the MLOps safety net, automated drift detection with evidently AI 2 and a retraining trigger. The idea is simple. Every night, a Kubeflow pipeline step compares the distribution of today's live inference data against your reference training dataset. If evidently detects that more than 15% of features have drifted beyond the threshold, it writes a drift flag to a shared config store. A separate Kubeflow step reads that flag and relaunches the full training pipeline from step 1. This closed loop means your telecom churn model always reflects current customer behavior without any human waking up at 2 a.m. to babysit it. Pair this with Prometheus alerting and your on-call engineer only gets paged when the automated fix itself fails. That is a mature, production-grade MLOps loop. Let us lock in everything you just built. You now understand the 5-layer MLOps architecture: data versioning with DVC, experiment tracking with MLflow, pipeline orchestration with Kubeflow, model serving with Selden, and monitoring with Evidently plus Prometheus. You wrote real code that trains a telecom churn classifier, logs it to the MLflow registry, detects feature drift nightly, and auto-triggers retraining without human intervention. That is a production-grade loop. Now for the most common mistakes I see teams make. Number 1, they version code but forget to version data. Always use DVC. Number 2, they skip monitoring entirely and wonder why accuracy tanks after launch. Number 3, they use the same data for drift reference that they used for training. Always freeze a separate holdout reference set before deployment. What should you build next? Add A/B testing with Selden's traffic splitting, wire Prometheus alerts to PagerDuty, and add a data quality gate using great expectations before training runs. If this helped you, smash the like button and subscribe for more tutorials every week.